Hello everyone, Mr. Clark here again from home, ready to do our next math. So if everybody gets their practice copy out, if everybody gets their calculator at the ready, and we will start to walk through the next math examples that we need to walk through. Okay, so if everybody goes to their list, we can see that we stopped at our bond beam block. Okay, so bond beam block is the next one. Okay, try and cover that up a little bit maybe. But again, we've got bond beam block, which is item number 10. Okay, so what did we say? We said that our bond beam, okay, is very similar to our lintel in that the block is the same basic shape. So if I'm looking at the face of the block or at the edge of the block, my bond beam block would be shaped like that. Again, I would place rebar in that bond beam. I would have vertical bar coming through, okay, at certain points of my wall, just like we talked about in our masonry lecture. I would fill that with grout and I would create a bond beam. And again, my bond beam is going to cover the entire perimeter of my building. Okay, so as I look at that, I can see that I'm going to have a bond beam all the way along the outside of my building, the outside perimeter. Okay, and I would see that bond beam, I would look down at it, see something like this running all the way across the perimeter of my building. Again, type of reinforcing, I would fill all those cores with grout and reinforcing, okay, and then tying that together with the vertical reinforcing would give me some additional reinforcing. So understanding that, again, we always go to our print. Okay, what do we see? If we go to our floor plan, okay, we can see we've just got the perimeter of our building, and knowing that it needs to continue the entire perimeter, okay, we go to our elevation and we see that that means that it has to be at the top of that tallest door in order to continue all the way around the perimeter. Okay, we've already discussed this. That's why we did not determine how many lintel block we needed at the top of that particular door. The rest of them we did. Okay, I can look at my elevation and I can see that it's at the top of an opening. Okay, and it has to be at the top of that opening because that's my tallest opening. Okay, so what are we talking about? We're talking about the perimeter of my building. Okay, so again, I need this perimeter. Okay, outside to outside. Okay, I have already determined that. Okay, but we can look at our print again and we can see that it's 40 foot 8 inches by 30 foot 8 inches. Okay. So we see that total perimeter, and again, thinking this through, what are we going to need to divide by? We are going to need to divide by the length of a block. And again, we know that a standard block is 16 inches by 8 inches high, and we're not concerned with the width. Okay, so first, I determine my perimeter. Okay, so first off, this is number 10 bond beam block. Okay, and I know that is going to be my perimeter divided by 16 inches per block. I know that perimeter is going to be in feet, so I'm going to have to convert my inches to feet. 16 inches divided by 12 will give me 1.33 feet. 16 inches divided by 12 inches per foot. My inches cancel. I get 1.33 feet. Okay? All right, so again, we've already determined our perimeter in an earlier step, okay, a couple of earlier steps, and you should be able to go back into your notes and pull that out. Okay, we don't have to determine it again, but again, we will look at it. It was 40 foot 8 inches times what? Times 2, 30 foot 8 inches times 2. Okay, good place to make another point. Okay, again, by doing this, what am I doing? Okay, I'm figuring in my corners twice. Do I need to do that? No. Can I do that? Sure. It depends on what I'm talking about. Okay, in this situation, we're talking about our bond beam block. And as you'll see as we move forward, we determine a high percentage waste factor, okay, on our mortar, okay, not necessarily on our block or our brick, but the point is, and we'll talk about that more when we get to mortar, the point is that masonry, with that particular trade, we have a high level of waste, okay? And because of that, if anybody's ever been around somebody laying block or they've been involved in a crew laying block, you'll know that. We crack a lot of block, we throw them away. We cut block, we throw the other portion of the cut block away. Okay, same thing with our mortar. Our mortar, we waste a lot of it. Okay, a lot of it falls onto the ground. Okay, so there's a high level of waste in masonry. And because of that, we're not going to worry about that. We're not going to worry about the fact that we're figuring in our corners twice because we know we've got a high level of waste anyways. Again, just a determination that I would make. Why is that important? Because again, what are we saying there? We're saying that we are the ones that set the math problem up. Okay, we determine what needs to be determined. Okay, and in this situation, I would reason that out. Okay, my logic would follow that if this has a high waste factor, I don't need to be concerned with being so accurate by determining out my corners. Okay, I am accurate enough by including those corners. Okay, so we can see this, and by adding those two together, we're going to get our perimeter. Okay, we have to convert them to feet. 40.67 feet times 2 plus 30.67 feet times 2. Okay, equals. Okay, again, you should have your calculator. You should be following along with me. Okay, that is going to be 81.34 feet. That is going to be 61.34 feet, which gives me a grand total when I add them together of 142.68 feet. Okay, again, we've already determined that once before, but that is our perimeter. Perimeter equals 142.68 feet. We've actually determined it more than once. Okay, but won't hurt us to review it. So again, from there, once we know how to set up the math problem and solve for whatever we need to solve for, very easy math. I have 142.68 feet, which is my perimeter, divided by the length of a block, 1.33 feet per lintel block, or per block. Okay, so we cancel out our feet, and we get 107.2 block. Okay, again, I could round that either way, 107 or 108 block. We will say this time that we have 107 block. And I would give you credit for either way, if you said 108 or you said 107. Okay, but we'll use 107 block. Okay, so finally, we have determined all of our accessory block. So now I go back to my lists. And I place that in my list. So I've got 107 accessory block. Okay, item number 10, 107 accessory block. All right, so now finally we can determine our total block. Okay, and again, as I pointed out before, why did we wait till now to determine our total block? Because I'm going to subtract out all of those accessory block, like the lintel block that we just determined. I'm going to subtract those from my total. Okay, once I've got my total number of block in my entire building, okay, I'm going to subtract that'll be my last step. I will subtract those from the total, and that'll give me my total number of block that I need to determine for my estimate, if I'm ordering it, on and on, whatever the case may be. All right, so for our standard block, our standard 8-inch block, so item number 11, eight-inch standard block for my wall. Okay. All right. So what do we have in this situation? Again, we go to our print. We look at our print. We understand what we need to understand from our print. And we know by looking at my floor plan that I have my exterior and my interior wall constructed of 8-inch block. And I see that when I go back to my elevation or to my section cut. Okay, I can see that both my interior and my exterior wall are 8-inch block from the foundation up. If you remember back to when we determined the foundation for the 12-inch block, that's easy to see. I've got 8-inch block sitting on top of that. Well, when we determined the number of block for our 8-inch foundation, we decided that my 8-inch foundation was going to be as tall as my 12-inch foundation. We made that decision. Again, we set the math problem up. Why did we determine that? I could have said that this foundation is 5 block high and this foundation is 4 block high, but I didn't, so that I could have the same numbers, so that I could reuse those same numbers. I said, all right, I've got this height of this foundation. I'm going to make this interior foundation the same height. Now I can just add all of those walls together to determine my net area. Okay, so again, we're the ones setting up the math problem. However I determine to do that is how I determine to do that. As long as I come up with the right quantities at the end, I'm doing the right thing. Okay, so what do we have here? That means that we have our wall exterior and we have our wall interior. Okay, why am I choosing to do that? Okay, hopefully some of you are guessing as to why I'm choosing to do that. Okay, what are we going to use to determine those two things? We're going to use our net area. Okay, we're going to determine our net area. Okay, if I look at my list, what do I see concerning my exterior net area? I go back to my I go back to my list. Sorry, this is easier when I'm in the classroom, of course. I go back to my list and I see right now we're on number 11. Okay, that's my 8-inch standard block. Next, we're going to be on my brick. Okay, if I look at my section cut, do I have any brick on my exterior wall? No, I do not. I only have brick on the, do I have any brick on my interior wall? No, I do not. I only have brick on the exterior wall. Okay, so that's why I separated the two. Again, I could set the math problem up so that I just include all of them in my total net area, but I decide I don't want to do that because I know I'm going to need just this exterior net area next. Okay, so I set my math problem up that way in order to be as efficient as possible. That's basically what it comes down to. All right, so we've got our formula is going to be my net area of my exterior times 1.125 block per square foot. Okay, again, we've already determined that. We've already determined that I use 1.125 block per square foot because when we looked at our foundation, we did the same thing. We used the net area and we multiplied it by 1.125, okay, by determining that I have 1.125 block per square foot. Again, how did I do that? Reviewing, I determined that the face of a block, 16 by 8, is 128 square inches. I divided that 128 square inches into 144 square inches per square foot. That gave me 1.125. My square inches canceled. I had 1.125 block per square foot. All right. Okay, so the same thing here for my wall interior. I'm going to have the net area interior times 1.125 block per square foot. Okay, so again, what do I have here? Okay, I've already solved for that. What do I need to solve for? I need to solve for the net area of my exterior and the net area of my interior. Okay, I'm going to erase this, so everybody write this information down. Okay, that's going to be my final formula, or actually my final formula would be those two added together minus my accessory block. Okay, but right now we're just focusing on this portion of the formula because we have to solve for our net area. We have already solved for that previous steps. We've already solved for those. We just finished it up. Okay, so now I have to solve for my net area of my exterior and the net area of my interior. Then I can solve for total number of block, and then from there I can subtract off my accessory block. All right. So again, this is our important formula right here. Tells me that I have to solve for net area. Okay, I'm going to erase that. We'll come back to that. Again, if I were in the classroom up at Ferris, I would be able to put all of this on the board, but I can't. Okay, so my net area is what I need to solve for. My net area for my exterior. Okay, what is my formula going to be for that? It's going to be perimeter times height, just like we did for our foundation, only now what do I have to be concerned with? I have to also subtract out my openings. Okay, so my formula for net area exterior is going to be perimeter times height minus my openings. My net area for my interior, okay, is going to be my length 1 plus my length 2. Again, we've already solved for that, okay, but that's what it's going to be, times my height, and then again, minus my openings. Okay, so again, we're just walking right through it. So next, I'm going to erase this formula. We're going to solve for this one. Then we'll put this one back up on the board, solve for that one. We'll have both of our net areas, okay, for exterior and interior. Then I can finally plug them into that final formula. Once I have that information, then I can subtract out my accessory block. Again, I could write that into this formula, but I'm not going to. Okay, everybody should be able to understand that the last step I have to do is subtract those accessory block. Okay, this is how I solve for the number of block for my wall. And then I just know that I have to subtract those out. All right, so let's solve for this formula first. So again, we see what? That I have to have my perimeter. We already solved for it. We just solved for it. We've actually solved for it several times now. Okay, so I could go back at any step. As long as my information is correct, I could just plug that information in. So that's what we're going to do. So net area for for exterior is going to be 142.68 feet, which was my perimeter. Okay, times what? Times my height. Have we already solved for that? Yes, we have. We solved for it a couple of times. We solved for it when we determined the corners of my 8-inch block. Okay, what did we do? We went back to our print. Okay, and we subtracted. We went to our elevation, and we subtracted top elevation from bottom elevation. So I subtracted 980, I subtracted 963.34 from 980. Okay, again, we've already done that step. I'm not going to keep repeating everything. Some things I'll repeat if they're important, other things I won't. Okay, all I did was I subtracted that elevation right there, okay, from that elevation right there. Okay, 963.34 from 980. And that gave us a height of 16.67 feet. Okay, so all I'm doing now is plugging in my numbers because I've already solved for them several times. Okay, now what? Now I have to solve separately for my openings. Okay, what do we have to do? We have to once again make a list. Okay, so down here we will make our list. Again, what do I have? I have windows. Okay, and my windows this time, what am I concerned with? I'm concerned with both width and height. Okay, so again, before as we've made our list, we were concerned with either width or height because we were either dealing with a vertical dimension or we were dealing with a horizontal dimension. But this time we're dealing with both. Why? Because I'm in square feet. So I will be in square feet. 142.68 times 16.67 will give me square feet. Okay, so I want to know the square footage of all of my openings. So again, I go to my schedules. Okay, I go to my schedules and I go to my floor plan. The schedule gives me my dimensions, so I can solve for that, and the floor plan gives me the number of. Again, we've already set a lot of this list up. It's a little bit different this time, but as we keep setting it up, we can reuse some of those numbers. Okay, so for my window number 1, I have 4 by 4, 4 foot by 4 foot. For window number 2, I have 6 by 4, 6 foot by 4 foot. For my doors, all right, so wrote windows there. Okay, so for my doors, I know I have door number 1, door number 2, and door number 3. Okay, I look at my first door, it is a 3 by 7. I look at my second door and I say, whoop, wait a second. Okay, again, I'm reading my print this entire time. Okay, and I'm thinking this whole thing through. Where is door number 2? Door number 2 is in the interior wall. So do we want it in this calculation? No, we don't, because we're solving for my exterior. So I don't have a door number 2 for the exterior. I will determine that door number 2 when I get to the interior area, net area. Okay, so I don't have a door number 2. I skipped that. Do I have door number 3? Yes, I do. It's 12 foot by 8 foot. Next, I go back to that floor plan and I determine how many of each I have. How many window number 1s do I have? I have 1. How many window number 2s do I have? I have 5. How many door number 1s door number 1s do I have? I have 2. How many door number 3s do I have? I have 1. Now, all we have to do is multiply that across and then add all that information together. That'll tell me my total number of square footage for my exterior openings. So 4 by 4 by 1 equals 16 square feet. Again, everybody should be doing this on their calculator, following along. 6 times 4, 24 times 5 gives me 120 square feet. So total for my windows, I've got 136 square feet of total space or opening for my window. Okay, 3 times 7, 21, times 2, 42, 12 times 8, 96, times 1, 96. I add those two together, I get 138 square feet. Then finally I add these two together, and I get a total of 274 square feet. Okay, that's the number I'm looking for, 274. I want my total exterior openings. So now I can subtract 274 square feet. Okay, give everybody a second to look at that. I know you can stop the video at any point. Okay, rewind it if you need to. Okay, before I erase it. All right, so now I can bring this all the way through. Okay, I can say 142.68 foot times 16.67 feet is going to give me an amount of square footage. And I subtract out my 274, which tells me that my net area, and again, everybody can do that on their calculator, my net area for my exterior is going to equal 2,104.48 square feet. Ultimately, that's the number I'm looking for my net area exterior. Okay? All right, so let's hold that number over here. Net area exterior equals 2104.48 square feet. Okay, so now let's go to our net area interior. So net area interior, if we remember back just a couple steps ago, equals length 1 plus length 2 times my height, okay, minus my openings. Okay, so length 1 plus length 2, already solved for that. Okay, again, it's just I have to determine from outside corner of my interior wall. Okay, if I look at my floor plan, the numbers I want are right there, 16 plus 9. Okay, 16 foot and 9 foot. All right, so 16 plus 9 is 25 feet. Okay, so I have 25 feet times my height. I just saw that, 16.67 feet. Okay, that minus my openings. Okay, so again, fairly easy math, but what's the difficulty here? The difficulty is knowing how to set the problem up. Okay, knowing what to solve for. Okay, so again, I go back to my floor plan, and what openings do I have to solve for? I only have to solve for door number 2. Okay, all right, I already saw in my schedule that my door, okay, I can go back to the schedule if I need to. The only door I'm concerned with is 3 by 7, and I have one of them. So I have 21 square feet of opening for my interior openings. Okay, so now that number becomes 21 square feet. Okay, so again, you can see how we're just sequentially walking through each one of these steps. So I go ahead and solve for that information. Okay, my 25 times 16.67 is going to give me square footage. I'm going to subtract out 21 square feet, and I'm going to get a total of 395.75 square feet. Okay, so there is my net area. Interior equals 395.75 square feet. Okay? All right, so we've solved for what we need to solve for. And now we can finally go back to our last formula, which is going to be net area exterior times 1.125 block per square foot plus net area interior times 1.125 block per square foot. Okay? Okay, or could I add those two together and then just put one formula up there and just say net area E plus I times 1.125 block per square foot? Sure, I could do that. Okay, and then finally, we will subtract out our accessory block. Okay, all of the block that we just determined. Okay, all right, technically, this guy should go in there. Okay, but everybody should be following along. All right, so let's go ahead and do it the way we had it set up. Okay, and again, just taking this out just so that we can see it. Okay, so that is going to equal my 2104.48 square feet times 1.125 block per square foot plus 395.75 square feet times 1.125 block per square foot. Okay, so we are going to get, let's see, equals 2367.54 what? Block, right? Square foot cancel. Okay, block for the top row, and we're going to get 445.22 block for that bottom row. Okay, and again, we're going to add those together, and that is going to equal a total of 2,812.56 block. Now, minus our accessory block. Okay, so that would be minus, I'll go ahead and list them all out. We're going to go back to our list. Okay, I'm going to go back to this list here. Okay, and I'm going to start with my 8-inch corner block. So my 8-inch corner block, I've got 4 of them. My, oops. Nope, I take that back. That was for the foundation, sorry. So starting at my wall, I've got my 8-inch bullnose block, 158 of them. Okay, I've got my lintel block, 41 of them. I've got my 8-inch corner block for my wall, 124 of them. I've got my bond beam block for my wall, 107 of them. So we are going to sum all that up, and then we're going to subtract it from that. Okay, and again, my units for those are block. Okay, we'll write that down next. So finally, I've got 2812.56 block minus 430 block. So that is going to equal 2382.56. Okay, again, we could round either way, so we're going to call that 2383 this time. $23.83 block. Okay? All right, so we are now finally going to write that in our list. Okay, so let's see here. Okay, number 11 is going to be my 2383 block. Okay, everybody should be following along with the list just fine. All right, so that's taken us what, about a half an hour? Okay, yep. All right, so now the next one we can see item number 12, and we'll finish off with this one. Is our brick for the wall. Okay, so again, we look at our print, okay, and we can see if I look at my floor plan, or if I look at, most importantly this time, my section cut, my elevation, I see that my brick is only on my exterior wall. Okay, my interior wall, my exterior wall. My brick is only on the exterior wall. We already determined that. That's why we said, okay, I'm going to set up my net area by exterior and interior, because my formula this time is going to be net area exterior times number of brick per square foot. Okay. Have we determined our net area of our exterior? Yes, we just did it. So that is going to equal, and again, what was our net area of our exterior? It was my perimeter times my height minus my openings. Okay, that is going to equal 2104.48 square feet times my number of brick per square foot. Okay, how do I know my number of brick per square foot? Again, reviewing what we did for our block. Okay, our block, we said, all right, a standard block, okay, is always 16 inches long. A standard block is always 8 inches tall. Okay, we don't care about the width because we're looking at the face area of that block. Okay, so we said, all right, if I take 16 times 8, I determined that I have 128 square inches. Okay, what do I want to be in? I want to be in square feet. Okay, just like with our block. So I've divided that into 144 square inches per square foot. My square inches canceled, and I got 1.125 block per square foot. Okay, that's what I used in my last calculation. Okay, so what did we do? We multiplied the length times the height. Okay, and what do we say when we're talking about block? We say that never changes and that never changes. But what do we know with brick? We know that length and that width constantly changes. Okay, every brick is a different dimension. So while that math is going to be the same, length times height, okay, we know that those numbers can be completely different every single time. Okay, and we know that how? When we think back on our masonry lecture, okay, we look at this chart that we received during that time. That is located on the back of your package for your practice copy. Okay, and we see that we've got two different charts right there, the top chart and the bottom chart. Okay, and we stated during the lecture that bottom chart gives me the dimensions that I need for my different brick. Okay, I can see that if I have a standard modular brick, okay, which is the first one, okay, I have my manufacturer dimensions and my nominal dimensions. Okay, for our calculations, we use our nominal dimensions. Okay, that includes my mortar joint. Okay, just like with my block. When we looked at my block, we said it was 16 inches by 8 inches, but we already know that it's actually 15 and 5/8 by 7 and 5/8, but we determine it with our 3/8 mortar joint, so we call it 16 by 8. Same thing is true with my brick. Okay, and if I look at this chart, I can see that my brick have all different dimensions. Okay, I have all different kinds of dimensions. I have some 3 1/5 tall, some 2 1/4 tall, some 2 13/16 inches tall, on and on. Okay, or I'm sorry, 2 2/3, 3 1/5, 4, 5 1/3, whatever. And I also have different lengths. I have 8 inches and 12 inches. Okay, everybody can see this. So what do we need to know? We need to know what brick we have. Am I going to decide what brick I'm going to lay on a building? No, of course not. The design team is going to tell me that. The architect is going to pick the brick. Okay, they have their criteria for doing so. Okay, so if we go to our section cut, okay, everybody can see right here where it said standard modular. I want you to cross that out and put engineered, because our specs, okay, everybody read their specs, tells us that it's an engineered brick. Okay, that was just a mistake on my part. I just didn't remember to change it. So everybody cross it out right here and put engineered, because we have engineered in our specs. So we find that we have an engineered brick. Okay, there won't be a mistake in your assignment. Just use it'll say the same thing. Okay, but we are going to call our brick an engineered brick. So I go back to that list, last page of my handout. I go back to that list and I find my engineered brick. It's the second one down. I go over to my nominal dimensioning, and what does it tell me? It tells me that my brick is 8 inches long, 3 1/5 high, and 4 inches wide. Okay? Again, we don't care about that number. All we care about is the length and the height, because again, we're concerned with the area of the brick, the face area. Okay, and what was our math last time? That times that divided into 144 square inches per square foot. So we start out taking that times that, 8 inches times 3 1/5 inches equals what? Okay, but I can't do that. I got to do what? 1 divided by 5. So 8 inches times 3.2 inches equals what? Everybody should be doing it on their calculator. And it comes out to 25.6 square inches. Inch times inch gives me square inches. Well, again, I want to know how many brick I have per square foot. So, last step I have to take is I have to divide 25.6 square inches into my conversion factor, 144 square inches per square foot. My square inches will cancel. Everybody do that math. And what do we get? 5.625 brick per square foot. Okay, this is actually 25.6 inches per brick. So my square inches would cancel. I'd have brick per square foot. Okay, so for our engineered brick, we have 5.625 brick for every square foot that we have. Okay, and again, what's important is that I have to determine that every single time. Okay, because my brick is always a different dimension. Okay, first I have to determine what brick it is. That tells me what my dimensions are. Then I have to do the math. Okay, I have to multiply my length times my height. I have to divide that into 144 square inches per square foot, my conversion factor. That tells me how many brick I have per square foot. Okay, that's what's important. I have to do it every time. Whereas with the block, I don't. It's always going to be 1.125 block per square foot. Okay, but with my brick, I always have to determine how many brick I have per square foot. Okay, but once we know that, fairly simple. I just plug it in. 25.6 brick per square foot. Okay, that's ultimately what I'm looking for. Okay, so we walk through and we do that math. If we have 2104.48 square feet and I have 25.6 brick in every one of those square feet, my square feet are going to cancel and I'm going to get a total of 11,837.7 brick. Okay? All right. Now, could I be done here? Okay? I could. Okay? Usually what a bricklayer will do is they'll add 20% to that for any accessory brick that they're going to need. But I'm going to walk through one of the accessory brick with you, really the only one we have in this situation, just so that you can see how to do the math. So we're going to hold on to that number. So at this point, we've got 11,837.7 brick. Okay? All right, then I'm going to go back to my print. Okay. Okay, going back to my print, I go to my section cut specifically. Again, ultimately, what are we talking about here? We're talking about the ability to analyze and interpret a print. Okay, I have to have the ability to get in and understand all of the information. Okay, I have to be able to understand the graphic information. I have to be able to understand the written information. And I have to be able to understand the mathematical information. Once I understand the mathematical information, I have to be able to set the math problem up accordingly. Okay, and this is a very good example of that. All right, if I look underneath that window, what do I see? Okay, my fingers are in the way. Okay, I see a roll-lock sill. Okay, so it's telling me that I have a roll-lock sill at each one of my windows. Well, what does that mean? Okay, well that means that if I have a window like this, okay, underneath it, I have a sill, okay, and it's in the roll-lock position. Okay, everybody again can refer to the handouts that I gave you when we had our original masonry lecture. And what does the roll-lock position tell me? That tells me that my brick is placed like this. Okay, if I look at my running bond of my normal brick, what do I see? My brick is normally placed like we just saw. Okay, my brick is normally placed like that. Okay, and another brick next to it. A roll-lock is placed differently. Okay, so that means that this dimension is going to be what? That's going to be this dimension. And that was what? 3 1/5 inches. Okay, or 3 1/5 inches. Okay, this dimension is now going to be what? My 4 inches. This dimension, 4 inches. And this dimension is going to be what? This dimension, my 8 inches. Okay, so the positioning matters. Okay, so when that brick is positioned like that, I look at this problem and I think, okay, up till now I've determined how many brick I have per square foot. Would that be the best way to do it in this situation? Okay, the answer is no. Okay, and some of you might be figuring it out. What would be the best way to do it when I'm thinking about the fact that I've got one of those roll-lock sills underneath each and every one of my windows? Could I determine the full lineal footage of my windows, add all the widths of each one of my windows up, and then calculate how many brick I have per lineal foot? Okay, that equals 1 lineal foot, or every 12 inches. Okay, could I do that? Yes, I could. By doing what? Dividing, okay, 3 1/5, okay, the length in this case of each one of those roll-lock sills into 12 inches per lineal foot, my conversion factor. Okay, yes, I could do that. And that's how we're going to do it. And I'm going to add that number to my total. Okay, so first thing I'm going to do is I'm going to determine how many brick I have per lineal foot. Okay, again, I know I've got 3 1/5 inches per brick. Okay, I want to know how many brick I have per lineal foot, so I divide it into 12 inches per lineal foot, knowing that my inches are going to cancel. Okay, we've got to do a conversion there. We have to convert that to decimal inches, and we've already done that. 3.2 inches per brick divided into 12 inches per lineal foot. My inches are going to cancel, and I am going to get, let's see here, I am going to get 3.75 brick per lineal foot. Okay, that's what I want. Okay, now what do I need to solve for? Now I need to solve for the width of all of my windows. Okay, again, I got to make another list. Okay, window number 1, window number 2. Am I going to put a roll-lock sill underneath a door? No. Okay, it's only going to go underneath my windows. So that's the only opening that I'm concerned with are my windows. Okay, so I look at that and I've got, okay, one window at 4 foot. I've got another window at 6 foot width, 4 foot width, 6 foot width, I've got 1 of those and I've got 5 of those. Okay, so 4 foot times 1 equals 4 foot. 6 foot times 5 equals 30 foot. So I have a total of 34 lineal feet of window width. Okay, so now I can simply say (34 lineal feet times, what was it? Just solve for it, paying attention, times 3.75 brick per lineal foot. My lineal feet are going to cancel, and what am I going to get? Everybody go ahead and do that math. I'm going to get 127.5 brick. Okay? So again, on your assignment, solve for your Rolox sill. Okay? And then add it to your total. So now I have 11,837.7 brick, and I have 127.5 ancillary brick for my Rolox sill. So finally, last step, I add those two together. I've got 11,965.2 brick, and we are going to make that. Again, I could round either way, but we'll say that we have 11,965 engineered brick for our wall. So I'm going to finally add that, or put that on my list, and everybody can see we've got 11,965 brick for my exterior wall. All right, perfect place to stop. Next time we will take a look at the next items, and that is going to be my mortar. Okay, and for my mortar I need sand and I need masonry cement, but we'll talk about that next time. So, all right, thanks everybody.